Good evening, everybody. Well, at least it's evening as I record this. Quick lesson on perfect cubes and cube roots. Now, this is incredibly similar to square roots and square root and the perfect squares and square roots, with the exception of negatives. So that's what I'm going to concentrate on first, and then I want to uh, give you an overview of kind of how this might look in a word problem. Okay, so remember, 2 times 2 times 2 is 2 to the third power. Okay, negative 2 times negative 2 times negative 2 is negative 2 to the third power. They do not both have the same value. They are separate. 2 times 2 times 2 is 8. Okay, but negative 2 times negative 2 is a positive 4. Positive 4 times negative 2 is negative 8. So we can have negative square roots. The negative or the cube root of 8 would be 2, but it can't be negative 2. Negative 2 is the cube root, and the little 3 goes right here, of negative 8. Because if you have an odd number of negatives, you have a negative, and the negative can be inside the cube root sign. It's fine. Okay. So to give another example, I'm going to ask you to be looking at your perfect cube root chart at a couple times during this lesson. If for some reason you don't have that, download one. Just Google perfect cube root chart and you'll find one. Let's say looking at the number 64. Okay. I know that 64 okay, is 4 times 16. And 16 is 4 times 4. So look at my factors of 64. Therefore, the square root of 64, or I'm sorry, the cube root of 64 is 4. It is a perfect cube root. And you'll see it there. Okay. Here's one that's going to look complicated, but not so much. The cube root of negative 343. If I look on my chart, 343 is just 7 times 7 times 7. 7 times 7 is 21. 21 times 7, 343. Okay, but it's negative. So I know this has to be negative 7 times negative 7 times negative 7. And that's really the main idea I want to point out to you in the difference between square roots and cube roots. Now, we're not going to assume, I'm going to take that word out, the use of positive value, but we're only going to use positive value. Okay. So for example, let's say I had a big cube. Okay. And let's say my big cube was Ignore my drawing. I apologize for that. Okay. But it was 3,375 cubic inches. Maybe it's an aquarium or something like that, right? That's the volume. And I know that volume is side times side times side. Okay, length times width times height. And in volume, or in a cube, they all have to be the same. So it's going to be, I'll use n. N cubed is going to be this amount, 3,375. So if I find the cube root of n cubed, I just get n, because they are inverse operations. If I find the cubed root, 3,375, well, how could I find that? With the reference tool you've been given. 3,375. So the cube has sides of 15 inches each. Now, we're not really going to approximate the cube roots, but I really want you to see their application when it comes to volume, because that is a way that we will be using them. Have a great evening. See you guys soon.